Hello students, today we're going to look at a couple of more solutions to some of your practice exercises. These are found on page 103 in chapter 7 of book 3 of your ma1025 booklets, and it deals with factoring the sum and difference of cubes. Okay, now as you see in the box in the right hand corner, I have already the pattern written there for the sum of two cubes right there and the difference of two cubes below it. Right? Sum meaning add, difference meaning subtract. Now you've already done some pattern factoring. You've already done this, for example, you've already done the difference of two squares, which is another type of pattern factoring. Right? You know that factors to a plus b times a minus b. And we've done those in previous videos as well. So pattern factoring is, you'll be given these cubic patterns. You don't have to memorize them, but pattern factoring is fairly straightforward if you do this step first. And the key is to write this as something cubed so you know what a is, and write this as something cubed so you know what b is, and then follow the pattern. So what is 64x cubed as something cubed? Okay, now if you're not sure, you can try for, you should know though that 64, the cube root of that is 4. In other words, 4 times 4 times 4 is 64. And x cubed, well, cube root of x cubed is x. So really, this is 4x all cubed. In other words, it's 4x times 4x times 4x, which is 64. And x times x times x is x cubed. Now, if you have a difficulty in a number and you're not sure what the cube root is, you can do that on your calculator. So let's jump over to the calculator. Under math, you will see the fourth button down is the cube root of something. So if you go down to number 4 here, so I want the cube root of that number so I can write it as a perfect cube. And you'll see you'll get 4, okay? So you can use the calculator to help you find those numbers. Alright, so the first one, alright, let's get rid of all that mess. And the first one, of course, I'm going to rewrite as 4x all cubed. And the next one is 27. How can I write 27 as something cubed? And the trick is, and I think most of you know this one, there's no trick to it, it's 3 cubed. And again, if you're not sure, math, go down to the cube root, double check it, the cube root of 27, of course, is 3. So 3 times 3 times 3 is 27. And that's the trick, because now 4x is a. Okay, this is a. Okay, so 4x becomes the a. That's right, and 3 becomes the b. And you just follow that pattern. So let's look at the pattern up here now for a cubed plus b cubed. So first it's a plus b. Now what's a? Remember, a is 4x. So it's a, which is 4x, plus, and then b, which is 3, times. Now you do a squared. So it's 4x all squared. You're going to square the 4x because a is 4x. Then it's minus, I'm just following this pattern, a, which is 4x, times b, which is 3, and then plus b squared. And b, of course, is 3, and I have to square it. And then just expand each of those, simplify a little bit. 4x all squared is 16x squared. 3 times 4, that's minus 12x. And 3 squared, of course, is 9. Okay? So there's the final answer to this one. Now, if you want to multiply it out to double check, you certainly can do that. I'll just do one of them. I won't do both. So let's multiply this one out and see what we get. So basically, it's the extended distributive property, right? I'm going to multiply by all 3 here. Then I'm going to multiply by all 3 here and see what I get. So I have 6 multiplications to do, okay? Alright, so 4x times 16x squared is 64x cubed. 4x times minus 12 is minus 4 12s are 48. X times x is x squared. 4 9s are 36x. If I multiply them by the 3, I get 3 times 16 is 48x squared. 3 times minus 12 is minus 36x. 3 times plus 9 is plus 27. Now what do you notice happens? Look, cancels. plus 36 minus 36 also cancels, and you're left with what? 64x cubed plus 27, which is what we started with. So you can check these by multiplying, but if you follow the correct pattern and follow A and B, you will get the right answer each time. Whoops, I'll leave that right there. Alright, let's do J. Now, remember the first rule of factoring is always take out a common factor. And this one has a common factor, I think, of 9. I think 576 is divided by 9. I'm going to go over here and check. 576 divided by 9. It is indeed. Okay, so let's take that out. So 9 is a common factor, and you must always remove a common factor first. All I'm left with then is s cubed minus 64t cubed. Now, ignore the 9, just carry it down each time. It's a common factor and it just stays out front. Now look at this. Can I factor this? In other words, can I write s cubed minus 64t cubed as the difference, which it is, of two perfect cubes? Well, we just had 64, so we know what that one is. So this is s cubed minus 4t all cubed, isn't it? With the 9 carried down in front. So what is s? S is your a. So this is a. What is b? B is 4t. Right? And this is, you're going to follow that pattern now as up here. We're going to follow this pattern now because it's the difference. So carry down the 9. Ignore it now. Let's follow our pattern. Well, for a cubed minus b cubed, it's a minus b first. Now a is s, so it's s, and b is 4t, so it's minus 4t. Then we do a squared, so it's s squared. Then you multiply a and b, plus sign, multiply a, which is s, times b, which is 4t, and then plus 4t all squared. Okay, so again, carry the 9 down, s bring down this one, and let's simplify inside. Nothing I can do with s, but 4s times 4t, I'll write as 4st, move the number in front, and 4t all squared, of course, is 16t squared. Now I won't multiply this one out, right, but you can, if you wanted to check it, you could multiply it out, and then multiply by the 9, and you will get the exact same answer you started with, I'm sure. Okay, so there's a couple of examples of factoring the sum and difference of cubes. Hopefully that helps. That's it for now.